Okay, let us continue the third part of today's class. Okay, we know that the expectation of ST is equal to P1, okay, which has been found in equation 5. And the expectation of S of t plus 1 is equal to P01 times P0 plus P11 times P1, which has been found in equation 6. Okay, now we need to find this term, that is the expectation of S of t times S of t plus 1. Okay, our idea is to find the joint probability mass function PMF of S of t and S of t plus 1 first. Okay, let P S of t S of t plus 1 of xy denote the joint PMF of S of t and S of t plus 1. Okay, then okay, then P S of t S of t plus 1 of 0, 0 is equal to the probability of S of t is equal to 0 and S of t plus 1 is equal to 0. Okay, then use the concept of the conditional probability. This probability is equal to the probability of s of t plus 1 is equal to 0, given s of t is equal to 0 times the probability of s of t is equal to 0. Okay, and this is equal to p0, 0 times p0. Okay, similarly, p s of t plus 1 of 0, 1 is equal to p1, 0 times p0. And ps of t plus 1 of 1, 0 is equal to p0, 1 times p1. And ps of t plus 1 of 1, 1 is equal to p1, 1 times p1. Okay, therefore the expectation of s of t times s of t plus 1 is equal to okay, is equal to summation xy is R in the set 0, 1 x times y times p s of t plus 1 of xy. Okay, and which is equal to 1 times 1 times ps of t, s of t plus 1 of 1, 1. And it is equal to p11 times p1. Substituting equation 12 into equation 7, okay, we can see that equation 12 is this equation, and equation 7 is this equation. We get P11 times P1 minus P1 times P01, P0 plus P11, P1. Okay, we can find these two terms have a common term, that is P1. Here is a P1. Okay, so we can move P1 to the leftmost of this equation. Okay, and in the parentheses, this remains term is P11 and minus okay, and in the parentheses, the remains terms are P11 minus P01 P0 minus P11 P1. Okay, we can see that the first term in the parentheses is P11, and the third term in the parentheses is P11 times P1. So we can move P11 to the front. So this is equal to P1 times, okay, P11 1 minus P1 minus P01 times P0. Okay. Okay, P1 and P11 here, and P11 times P1 here. So here is a term minus P1, and minus P01 times P0 is moved to here. Okay. Okay, please note that 1 minus P1 is equal to P0. Okay. Okay, so we have another common term P0 and P0. So we can move it out of the parentheses. Okay, please wait me for a minute to save this file. Okay. Okay, so after move the term P0 in front of P1, we can get P0 times P1 and times P11 minus P01. Okay, minus P01. Okay, when P11 is greater than P01, the covariance of S of t and S of t plus 1 is greater than 0. Okay, because this term is greater than 0, and it is naturally to assume that P0 and P1 are both greater than 0. So it corresponds to the case where the channel states in two consecutive slots are positively correlated. So this completes the solution of this problem. Okay, do you have any problem or any questions? Okay, if you do not have any questions, let's go back to the handout. Okay, so we have shown that P11 is greater than P01 corresponds to the case where the channel states in two consecutive slots are positively correlated. Okay, next we are going to go back to the slides. Okay. So with a unit reward for good state and 0 reward for bad state, okay, this can you can see this in paper Zhao et al. 2008. Okay, this paper Zhao et al. In 2008, which is a paper published in IEEE Transactions on Wireless Communications. And Ahmad et al. In 2009. Okay, Ahmad et al. In 2009. Okay, this paper, which is published in IEEE Transactions on Information Theory. Okay, and Ahmad and Liu in 2009. Okay, Ahmad and Liu in 2009. Okay, which is a conference paper published in IEEE Annual Allerton Conference on Communication Control and Computing. Okay, in Liu and Zhao 2010. Okay, we see that Liu and Zhao in 2010. Okay, it is also a paper which is published in IEEE Transactions on Information Theory. Okay, and Liu et al. 2011. Okay, Liu et al. In 2011. Okay, it is a conference paper which is published in IEEE Conference on Decision and Control, CDC. Okay, the indexability of a special classes of RMAB has been established. Okay, what is the indexability? Okay, let us see the handout. Okay, what is indexability? Okay, answer. To introduce indexability, it suffices to consider a single arm due to the strong decomposability of Whittle index. Okay, we will see what is decomposability and Whittle index in the later problems. Consider a single-armed banded process, a single channel, with transition probabilities PJK, okay, where JK are in the set 0, 1. Okay, you can refer to this figure. Okay, refer to figure 8. Okay, the Gilbert-Elliott channel model. And bandwidth B, here we drop the channel index for notation simplicity. Okay, that is, we do not say B1 or B2, we just say B. Okay, so there is an assumption here that there is a single channel, so there is the bandwidth B. In each slot, the user chooses one of two possible actions. U is in the set 0 and 1. So 0 denotes the passive, passive actions. Okay, so you do not pull down the arm, of the slot machine. And 1 for active. So it means that you pull down the bar or arm of the slot machine. Okay, like this. Okay, you pull down this arm or bar of the slot machine. Okay, to make the arm passive or active, an expected reward of omega B is obtained when the arm is activated at belief state omega, and the belief state transits according to the following equation. Okay, omega of t plus 1 is equal to p11 if I is in u of t and st is equal to 1. Okay, it is 25 minutes now. Okay, So see you next time. Goodbye.